My name is Ed Horley. I'm on the California v6 Task Force, and I've been asked to moderate the room and just do introductions for the speakers who are going to be coming up and presenting. Hope to try and keep them on time, so I'm the one who yanks them off the stage as they go over, with the exception of the last one. Christian, if you want to run over, you're the last one of the day. You're just keeping people from beer, so hey. But with that, I wanted to welcome everyone. Thank you so much. We're here for the IPv6 track, the IP track specifically. And am I early on time? I don't think I am, because I want to get you going right away. So with that, Tim's going to be coming up. Tim is the product manager and director for BT Diamond IP, which offers IP address management appliances, software, managed services to enable customers to effectively manage complex IP networks. Tim is responsible for direct product and feature development, maximizing profitability, who isn't, right? Managing partnerships, supporting sales and marketing, technology development, and otherwise supporting product-oriented organizational functions. He's held this position for over 10 years. He's instrumental in the success and launch of the IP Control and Sapphire product line, as well as BT Diamond's IP-managed IPAM service. Prior to joining BT, Tim held a comparable position at Lucent Technologies and has worked for Comcast, AT&T Bell Labs. He recently co-authored 3 books on IP address management and IPv6 with Wiley, the IEEE Press. And he holds a BS in Commerce and Engineering Science from Drexel and a Master's in Electrical Engineering from Rutgers. So welcome, Tim.
Thank you very much, Ed, and thank you all for attending. So what I'm going to talk about is IPv6 address planning and allocation strategies. Sorry, okay. Is that better? So what we're going to talk about is, how to devise your IPv6 address plan. Does anyone have one today that they're employing? Okay, we have a few takers in the room. How many times did you end up redoing it? Once, twice, 3 times? Okay, that's pretty common, and it's actually a good thing. So I think really one of the processes that we have defined in the IPv6 deployment and management book is basically an authorization process, a planning process, and then deployment, management of the dual stack network, and finally retiring IPv4 at some point. So it's really the planning that is the key, and that's what we're going to talk about today. So redoing your address plan is fine. It's better that you redo it now than before when you implement it in your network. So we're going to talk about maybe, I want to provide some food for thought for you to maybe think about address planning, not so much just about your router topology, but maybe about other areas that may simplify life after you've deployed v6, like security management, even network management of your network. So hope to provide some things to think about there. So we'll talk about the context of address planning from the overall IPv6 deployment process, just to kind of put things in context. Then we'll go into the address plan itself. What are the goals? Why do you need an address plan? We'll talk about some of the techniques or the mechanics of address allocation. And then we'll go through a couple of examples where we talk about, the different scenarios of how to allocate. And at the end, I'd like to do just a quick demo. We have a free web tool that we've developed. And there's a link to that in the presentation. But it's basically just a way to play around with different layers of address allocation that I invite you to use at your convenience. So with respect to the overall IPv6 deployment process, clearly IPv6 is going to impact every aspect of your network. So from your routing infrastructure, switches, to the computing devices, servers, end user devices. And unless you bought all your network components maybe 15 years ago and haven't upgraded them since, you probably have IPv6 capability on all of those elements of your network today if you've got recent vintage operating system versions of these various components. So, but the one thing, so typically customers or people wanting to implement v6 will do an assessment of that just to verify there may be certain features that you want in v6 that you want to verify with respect to these components that are in use in your network. Applications as well, typically all the standard IP applications like FTP, DNS, DHCP, they all support v6 natively. However, if there are any specialized applications, you want to look at those, and also databases. And then so beyond the networking equipment and component piece, there's now the management piece, the operations side of IPv6 deployment. And that really deals with, your way of deploying your security. How do you want to secure IPv6? How do you want to manage the network when you've got IPv6 running? And then finally, of course, IP address management. So you really, to implement IPv6, of course, you need IPv6 address space. And, certainly the most common way of managing address space today is probably using a spreadsheet, which probably works pretty well for v4, but may be a little more challenging with v6 with a hexadecimal. But nevertheless, we're going to use an example of that in the talk here, and we'll just kind of give a scenario of how that might work. So we talked about where do you start when you're planning an IPv6 address plan. Well, a logical place to start is where do you have address space today? So the IPv4 baseline, basically identifying where you have address space, what devices, what different sites you have, your hierarchy of your network, how many end users you have where, from a sizing perspective. So that's all very important input because presumably, at least at some point, when you fully deploy IPv6, that same set of, at least end users will perhaps require IPv6 addresses as well. There may be different intervening layers, as we'll talk about, but the end result is that the end user community using v4 today will be able to use IPv6. Now, that provides a baseline from a capacity and location perspective, perhaps, but not necessarily from a plan derivation itself. The number of layers and the way you've subnetted v4 may not be the right approach for the way you want to do IPv6. It's really an opportunity for a fresh start, fresh way of thinking. You've got a lot more address space, so maybe a more deterministic approach. I think many of us built v4 networks based on ad hoc requests. Well, I need this. Okay, well, let me add that to my v4 plan. Oh, I need that. Let me add that. So given that experience, let's try to leverage that and employ that into our IPv6 plan right up front. So in terms of your address plan impacts, if we go back to Router 101, routers basically are responsible for routing IP packets across your network, ultimately to end destinations. And they do this based on really three pieces of information. The packet information, the packet header, including the source and destination IP addresses, IPv6 in this case. Also based on routing tables that the routers dynamically manage. And then thirdly, based on any policies that you might set up for perhaps differentiating services. Voice maybe gets lower queuing delay, et cetera. So the various policies that you implement are also impact how those packets are routed. So that's kind of an input to that process. And obviously, there's an IP address component to that. Likewise with security. So security devices filter traffic, and that too is based on typically information in the IP header, your IPv6 source and destination address. So you can start to see that the address plan may actually have an impact on these various components, and we'll talk about how that might play out. So your goals of your address plan are really, at bottom is really to provide IP addresses to those that you need to have access to your network. So from an enterprise perspective, those end computing devices that you have that you want to provide IPv6 addresses to would need to have be provisioned with IPv6. And these addresses are really provided in order to enable nodes to communicate either with each other within the enterprise network or not. There may be certain users that you don't want to access. You don't want salespeople to access the payroll system, for example. And also to enable internal users to access external resources or not, whether it's partner links, the internet, et cetera. So the IP address policies can help you simplify those rules. So how you define, your address space can have an impact on whether these nodes can communicate or not. And also to enable nodes to communicate via supported media. So whether it's voice over IP, video over IP, et cetera. Some of those routing policies we touched on can also have an impact on providing communication via that media. And then, of course, security and network management. I touched on that a little bit earlier. So we'll see how your address plan should consider these items and if it could play a role in your network plan, your address plan. Okay, so before we go into a couple examples of address plan, I just want to touch on some of the mechanics of IPv6 allocation. So basically we have When you go to your ISP, you get a global routing prefix. Typically, your interface ID is going to be 64 bits. According to the IETF IPv6 architecture, all unicast address space that has been allocated requires a 64-bit interface ID. So your subnet ID is basically that set of bits that you have to play with respect to defining your address plan. In this simple example, we're just going to use 4 bits just to keep it simple and so it doesn't go off the page. But here we just basically monotonically count 0, 1, 2, etc. Pretty simple way to allocate space. Another mechanism is using sparse allocation. And here we're counting, but we're reversing the bits. So we're counting 0, 8, 4, C. So you see how the bits are reversed. I'm the same counting, but I've reversed it. And the effect of this is to allocate space really as far apart as possible. So if you're an ISP, for example, it makes sense to allocate sparsely so that should a customer come back to you and say, I need more space, it's more than likely that the adjacent block may still be available. Okay, so you can just say, okay, great. Instead of I gave you a 40, now I'll just change that to a 39. So that'll take up the 2 40s basically that are hopefully still adjacent and available. Best fit, many of you having done V4 address allocations are familiar with this. Basically provides a way to allocate the smallest available block. It does optimize network efficiency. So in this example, if I needed a 37 next, I would just pick that. I wouldn't have to try to cobble together a bunch of 40s, for example. So it just provides a means to maximize your address allocation efficiency. It's probably less of an issue with V6, so it's really here for completeness. But in general, you probably want to do your layers in same-sized allocations as opposed to the variable length subnet masking that was so popular with V4. Random, I could randomize these 4 bits and assign them as subblocks. That might be more useful at the lower levels, your subnets, if you want to basically make it more difficult for someone to guess the next subnet that I've assigned by randomizing it. And then also prefix delegation is not so much a technique, but it's more of a mechanism, using the DHPv6 protocol to allocate address space. So in terms of now defining your plan, one of the things that are defined for IPv6 address plans for the regional Internet registries is hierarchical. Okay, so the hierarchy is critical to enable you to aggregate address space to assign from aggregates or hierarchy levels so that the address space rolls up. And to illustrate how that might look, when you get your address space from your ISP or your regional Internet registry, or if you're using unique local address space, you want to define the sub-allocations in a hierarchical manner. So here I've allocated my level 1. I've got 3 blocks that I've carved out. And then below each level 2 is now I have sub-blocks under each block. And at level 1, I've really aggregated that sub-layer, including the layer below and all layers below that. So the hierarchy gives you a way to really summarize address space in accordance with the level for the intention of that level, which historically has been geographic. However, as we'll talk about, it could involve applications or business units or other aspects. Down at the node level, address assignment policy, DNS, is going to be critical for reachability for IPv6 just because of the address is going to be difficult to type in for someone to access. We'll talk about that a little bit later. But moving on to an example, let's go to the traditional geographic model. So here I've got my 2001 DB8/32, my typical reference network. And what I want to do here is carve this up on a 2-layer hierarchy. So I've got really my core level where I've got my headquarters. I've got an office in Philadelphia. I've got Tokyo and Dublin. So what I want to do is I'm going to carve this block, or I'll consider it a piece of pie here, just because we used that view a little bit earlier. So what I want to do is carve out of this pie and assign it to my sub-layers below that. And so basically, let's say I want to carve out /40s. So what I'm doing here, instead of using the 0 subnet, which is difficult to measure, I'm going to use the F0 subnet to start with, and then monotonically allocate /40s from that pie. These slices are not to scale. Actually, these 4 pie slices comprise 1/64 of the entire pie there, but just to illustrate. So basically, I've taken my /32, I've carved out chunks of my pie, and now I'm left with not a /32 anymore. I actually have a 33, 34, etc. as listed there, because I've pre-allocated some of that space. Now, I could have basically just taken my /32 and done a split down to 256/48s, just to kind of get it over with. So that might be another way to do it, where you end up with 256 entries, whereas this is a little simpler because I've summarized it. But the nice thing about this now is that I've allocated at this first level, and I basically am saying that, okay, this is hierarchical. I want to make sure these all roll up. So this, in essence, becomes my pie at the next layer. So now I've got address space, aggregate space in each of these core sites that I can then further allocate from to assure that it rolls up. So let's say in Philadelphia, for example, I want to take that /40 and carve out /48s. So again, using a monotonic type of allocation approach, I can just allocate space to each branch office and distribution center as required. So in this case, again, I'm not left with my F100/40 anymore in Philly, but I'll leave it as an exercise for you to confirm that I have a 41, 42, 43, 44, 45, and 3 48s. So the idea here is that you create these pies from sub-pies, and then ultimately you end up, maybe each of these buildings and distribution centers has different subnets or different floors, different applications that you want to allocate for. So to try to put this in a little more concrete terms, we'll go through an example, but first just to summarize some of the guidelines to think about. So clearly, defining your addressing requirements, again, where do you have address space today? Where do you need to allocate space? And again, the V4 baseline might be useful input for that. But also think about other aspects that you might, that have impacts on your IP address space. What policies do you implement that are based on IP address? So from a security perspective, network management, from a certainly routing topology, but also administrative delegation. If you need to carve out different administrators, if you're doing a lot of mergers and acquisitions, for example, you might want to reserve space for that to the extent that you want to give up control to the other organization. And then also just general management controls based on IP. So give some thought to this, and we're going to, again, walk through an example. But based on that, you can help start to define your layers. Even if you've got a very flat network, you might want to consider implementing a couple different layers. And hopefully, as we go through the examples, that'll become a little clearer exactly why that is going to be beneficial. In terms of the actual strategies at the allocation, once you're ready to do the allocation, we talked about the mechanics, sparse and best fit and so forth. But we do recommend Nipple Boundary allocations, 4-bit allocations. It's not required. However, it makes it much easier for you when you have a plan to look at an address by site to be able to identify a hex digit as having a particular purpose or particular meaning. Also makes DNS a heck of a lot easier. So if you've got IP6.ARPA zones that you need to manage as well, keeping them to the hex boundary is going to help eliminate the need to implement an RFC 2317 style implementation of reverse zones where you've got to create a bunch of zones with CNAME records and consolidate them back. It just becomes very challenging to manage. So keeping things on nibble boundaries is certainly makes life a lot simpler, and I think that's really the best approach going forward. Just keep it simple. And we also, typically if you're an ISP, we certainly recommend sparse allocation in general for the reason I mentioned. But even in an enterprise organization, it might make sense to allocate that way. Well, there's actually an additional technique that I didn't mention, and that's like center counting, which is kind of an adaptation of the sparse algorithm. But that might be another approach that you want to take as well. So let's look at an example here, and certainly you want to track your allocation. So your plan needs to be documented clearly so that you've got a marching orders to implement in your network. And what I've got here is I basically just have a spreadsheet showing the allocations that we made in our network map a couple slides ago. So I've got my regional offices, and I've got within Philadelphia, I've got the indebted address space, my 48s, which are really driven from the Philadelphia block there. So the indentation there indicates that. So if we just kind of do things as we've done historically with IPv4, let's just say, okay, this is a plan that works great. Now let's say somebody comes and says, well, we need to implement different routing policies in our network. We need to now set up policies for data. Maybe we need to route voice differently, maybe even wireless, and I need a management subnet so I can kind of cordon off my NOC network. So, as an address planner, you might just say, okay, great, I'll just allocate more space. I'll just add another set of columns here. Maybe even allocate an additional /40 for each of these applications to each regional node, as we've illustrated here. Now, a better way to do this might be to actually use the /40 you've already allocated. Okay, so you've got better utilization of your address space, if that's a consideration. But if we just kind of continue with our example, so I basically just monotonically counting up my address space here. So, it's great, we've got /40s everywhere we need it. However, by doing this kind of willy-nilly approach, I end up not really having a good mechanism for being able to define, well, for my branch 1 office, the address space is, if we look at the third sedectet there, the F101, the F501, and F901, et cetera. So there's not really an intuitive way to say, okay, well, that's the branch office 1 location. So, 1 plus 1 times n, n times 4. You could get into some strange algorithms, but obviously that's not going to be a by site recognition. So as we go through our examples, we'll see how you can improve that. Now, it might be that, okay, well, now I have another request. Maybe the engineering team wants to manage their own address space, and maybe I want to give different administrative delegations for different teams to manage their own address space, different business units, maybe, again, mergers, different organizations. So, again, I just kind of can allocate additional address space for that. And, again, you see that it follows a similar technique, and maybe if production needs their space as well. But you end up with basically just a bunch of address space that really certainly meets the need of allocating space to where it's needed for the purpose of the application and the organization that's managing it, but it doesn't really give you a very intuitive way to recognize that a given address is for operations wireless in Philadelphia, for example. So we're going to talk about how we make that a little bit simpler. So if we start with our 2001 DB8/32 once again, and now we're going to say, okay, I want to cognizantly now make this hierarchical. So I'm going to say, okay, my first allocation is going to be by application. So here I want to just say, okay, on my data space, I'm going to look at the next nibble of my allocation, the 30 bits 33 to 36, and I'll assign 0 to data. Here I'm actually doing a sparse allocation, 8 to voice, et cetera. And the benefit here is that now I have basically one routing policy that I need to put in my routers. Okay, so all the voice traffic is going to be routed based on addresses having that 8,000 value in the second sedectet. So if I need to make a change, that's going to be quite simple to do. Okay, I've got to change on my routers, but I only have one policy entry that I really have to change. Let's look at the next layer. Let's say now we do it by geography. And here you can see that for the voice component, I've kind of drilled down into that piece. And you've got it by the 4 regions that we had in our network map. Okay, so here you can see that now I have some logic here. Okay, so if I wanted to look at the wireless space in Dublin, then you can pretty much conclude that's going to be 4400. So it becomes a little more intuitive, and over time it actually becomes something you can recognize by sight. And then finally, let's say I want to do an administrative delegation by business unit. Each of my different divisions needs their own address space to manage, or again, I've got different units coming on board. So let's say I've used the next 2 nibbles for that. And so what you have happening here is that at the core router level, those 4 regional routers, instead of just having one route, the /40 as in the example, I now have up to 16 based on how many applications I've defined. Okay, so you basically have the number of routes based on your previous layer allocations. So you could have up to 16 routes in your core routers. So maybe not such a big deal. At your business unit level, you basically could end up with 256 blocks that you're giving to each business unit. Okay, engineering, here are your 256 allocations. You get 1 per my 16 applications, one for 16 sites. Again, if you have less, it's going to be less than that, but your upper bound is going to be in that manner. So my business units then end up having a lot of address chunks that they need to manage for whatever reason, to the extent that they support all those applications and regions. From a security perspective, now it really comes back to, well, what are some of your more frequent activities from a security perspective? Do you need to shut off a location? Do you need a business unit entity to be shut down? So as you go further down in your allocation, your security policies are going to get more involved, more entries in your policies tables to enforce those policies. So that's just something, again, to think about with respect to your activities in your network. So here we see it by application, quite simple, to set up policies, to set up routing, to make changes, which is the management piece that you're going to be managing over time. And then at a regional level, not so bad. And then application, it's a little more involved, or a business unit level. Let's look at the same example. And again, I encourage you to create multiple address plans. It's good to take a look at multiple versions just to see what the trade-offs are. And if we take that same /32, and now I'm going to allocate my top layer by business unit. So I'm going to take those same two nibbles and allocate by business unit. And again, you see that by site, I can recognize, for that business unit for finance, it's 8,000. And each business unit now just has one block. So instead of having 256, I've got one address block that I need to manage. It makes it easier for that team. And then maybe the next layer is by application. Okay, so again, by application, depending on how many business units you end up with, if you do use the full 256, then you're going to have 256 application entries. Okay, so each application needs to apply to each business unit, basically. So you could end up with quite a few application treatment policies, if you will, in your routers to enforce those policies uniformly across your network if that's a requirement. And then thirdly, again, by region. So now I get down to, again, the last nibble of that second sedectet to assign here. But you can see that, the logic here does give you that ability. In this example or the prior, the red highlighted bits or nibbles here kind of enable you to quite easily map, Corp, wireless, voice Tokyo is easily derivable over time. I think maybe initially it might be a little tough, but I think over time you learn that these hex values have meaning and how they roll up. But the order in which you do these allocations, however, is going to influence your kind of ongoing management. So once you've implemented your V6 plan, now you've got to manage that network. And those policies that you have defined based on IPv6 address are going to be influenced by that. The number of entries or changes you need to make in your network infrastructure to enforce a given policy or to shut off a unit or what have you are going to be influenced by the layers, the ordering of the layers that you implement. So, for example, from a security perspective, in this example, if I more frequently have to shut down a business unit, they need to be shut off the network, then it's quite easy in this example to do that. One entry and I'm done. But if it's, as you go down lower by application, becomes more entries and finally by region. So if you need to shut down a regional office or a region within your network, that would involve a lot of entries. It would also involve a lot of routing table entries in your routers. And that really is going to be up to your network and your topology, your infrastructure that you're using if 2 to the 12th is a big deal in your routing tables. So, you end up with up to that amount based on, again, the number of applications and business units that you have in your network. And so these are these two examples are just using these three criteria, core level, a business unit, and then an application. But you may have additional criteria to think about. Again, think about your IP-based policies that you implement in your network. So to summarize, basically, to think about that. Think about things that you've had to do in the past. Shut down an office, throttle an application. And so that could provide you, it's no guarantee that something else might happen in the future that might involve something different, but it's probably a good indicator of going forward how you might need to manage and really plan for in your IPv6 address plan. assess, contrary to that, depending on where in the layer structure your geographic comes into play, consider your infrastructure and their capability to support multiple routes. If you're an enterprise, it's probably not that big a deal. If you're a service provider, now you've got to conserve that routing table. Okay, so that's something for you to think about in the scope of your network. And then the homogeneity. Do you need to have the given application for every business unit routed the exact same way everywhere? That would certainly be simpler, but if it's not as big an issue, if it's not policy affecting, then you can put that lower in your hierarchy because it's not going to have as much an impact on your changes. Again, the lower in your hierarchy you are, the more entries you're going to have to make in your routers or your firewalls or what have you to enforce those particular policies that you want to implement. Also, administrative delegation, giving a certain organization access to their own address space or portions of the network. That may be an issue for you as well as segmentation, disallowing communications. And really it comes down to prioritizing these actions or these potential actions given your history, your plans going forward, and your infrastructure capabilities. Now we finally get down, once you've got the address plan piece, that kind of gives you your structures. That's why we really emphasize taking the time to maybe run multiple scenarios, think about the trade-offs of each of the approaches, and when you finally get a plan you're happy with, of course, Murphy's Law will inevitably kick in and you may have to, change something you hadn't foreseen. But again, given experience, hopefully that will be minimized. But certainly, from, again, an IP address management perspective, you want to make sure you manage not only the v6 space you're planning, from an address planning perspective, but also your current v4 space to the extent you'll continue to support that for some time to come. But getting down to the host level, managing, being able to track that, you're going to definitely want to track the IPv6 addresses assigned to your hosts. What are your policies maybe for routers? I'm going to statically assign those addresses. Maybe I'm going to allow certain devices to auto-configure. Others, I want to have control of the address space that I give out, so I'm going to define DHCP-v6, and I'm going to configure my routing advertisements accordingly. From a DNS perspective, again, mapping your host names to IP addresses certainly makes it easier to navigate than typing the IPv6 address. And then on the IPv6.ARPA side, in the worst case, you're going to have 32 nibbles separated by dots with the IP6.ARPA suffix if you need to configure your reverse zones. And we see that a lot, for VPN applications. A lot of VPN applications will check the existence of a DNS record for that IP address that's trying to contact me. There may be other applications that rely on that as well. So again, DNS is a key consideration in your IPv6 address plan, and as you can see, it gets rather lengthy from configuring that in DNS. So again, IP address management. So you're going to want to use a system that's going to enable you to define these various scenarios, play with them, look at the various trade-offs of each, and really manage those addresses going forward. So once you've defined, converged on a plan, implementing the plan, tracking the implementation with your deployment will enable you to track that space. And it's really important, for example, if you do lose connectivity to a given site, you don't want to be asking, well, what address space did I have out there again? You want to have a record of that so you're able to bring that back online or troubleshoot individual desktops, for example. If you ask the user what their IP address is, you might get a blank stare or silence on the phone. So again, keeping track of that in an IPAM type solution, whether it's a spreadsheet or a more sophisticated solution, is highly recommended. With a commercial IPAM system, the spreadsheet's great, it's free, but it doesn't really give you a lot of the advanced controls you may require, again, depending on the extent of your network. Providing simplified address allocation. A lot of IPAM systems and spreadsheets are easy to use at the host level, or maybe at the subnet level, but not so much at the block level. So I invite you to our booth number 1, to check out how we can, just with a few mouse clicks, allocate your blocks quite easily and seamlessly. Also provides additional functionality in terms of tracking addresses through discovery, administrative controls, auditing, that types of things. The things you don't get with a spreadsheet that can help you to keep tabs on what's going on with your IPv6 network to make sure the plan is being enforced or provisioned in accordance with it. And then, of course, APIs, CLIs, so basically integrating IPAM. Again, it's a core network function, network management function. So integrating that with other network management systems, provisioning systems, et cetera, automation, either through an ITIL type environment or FCAPS, whatever your approach might be there, that can just save time, reduce errors in provisioning in your network. Okay, so additional resources. We have a lot of additional resources on our website, white papers, surveys, books even. So we're actually having a book signing at the Beer Garden, so if you want to stop by booth 1, we invite you to do so for the IPv6 deployment and management book. And we've got a variety of resources here. So one of the resources we have, and this QR code points to it, and this Google short URL. I'm just going to jump out here and show you an example of this tool free tool we developed. So if you click that URL, you're going to get to this page on IPAM Worldwide. So again, these are free IPv6 tools that we've developed, and they're really just little utilities to enable you to learn more about v6, to get comfortable with it. With respect to a needs assessment, very qualitative, a subnet calculator, pretty standard. The last one there is the ROI calculator. So if you're looking to justify financially IPv6 to your organization, it really takes the position of an external web access and what's it going to cost you and what are your revenues, how might your revenues be affected if you don't implement v6 versus if you do. So just a nice tool there. But I wanted to focus for the sake of this talk on the address planner. So what this does, oops, there we go. Okay, so let me just maximize this. So again, it's a free tool. You just basically enter whatever your source block is. Again, it defaults to the reference block 2001 DB8/32, which is what we're seeing on the screen here. So that's my source block. There we go. Okay, so now I want to add a layer. Okay, so basically just click the Add Layer button. And what I can do here is define the purpose. Let's say it's by application. Oops, sorry. If I can type, there we go. Now, you can also, this checkbox for enforced Nipple applications, you can either turn that on or off. Again, we recommend that, so it's defaulted on, but you can uncheck it. But basically, let's say we want to allocate 4 bits per our example before. Just gives you a, subnet number 1. Again, initially we had done this as subnet 0, and every subblock looked the same. So, we basically use subnet number 1 of layer 1. And if you actually click on this, you see that there's a badge there, 16 of those. Tells you how many. And let's see if I can find my mouse. If you click on this, there we go. So you'll see the corresponding blocks. Okay, so it just gives you that summarization there, highlighted in the color as appropriate. And then if you want to add another layer, you just come back to the home. Oh, that's help, I'm sorry. We do have help as well. But if you come back to the main screen here and add another layer. Let's say I don't want to do nibble boundaries, so I uncheck this. And it's kind of hard to see here, sorry. So let's do 6 blocks, or, well, 6. And we can add another reason here. You don't have to, it's just a... Okay, so now I'm allocating 6 bits, again, not recommended, but just to illustrate that you can do that. Then we end up with our layer 2. And to see why, one example of why it might not be recommended, you can see how the digits there are skipping, 048C, 048C. So you end up with an allocation that is non-linear, if you will, or non-monotonic. So again, it's legal, but again, not recommended. So again, this is delving into the first subnet and the various subnets there. Okay.
What's the URL?
It's www.ipamworldwide, all one word, .com/libraries/toolmenu.html. Sorry. Or the short URL is on the screen there. We'll just jump back to that. Yeah, it was. Here, let me... Okay, let me jump to that slide here. Okay. This is strange. Sorry about that. I seem to have... While I'm doing this, if you want to start the questions, if anybody has any questions, I'm going to just bring up that last page again. Thank you, Ed.
Questions?
I guess it's only in PowerPoint mode, okay.
I'm just curious if you would ever recommend some sort of a hybrid allocation strategy where, say, voice over IP, we're going to, manage that sort of globally for the organization under one space, but then, data networks we're going to assume have varying security requirements and stuff, and so you've got, VoIP up high and then business units sort of at the same level or something like that.
I see. Yeah, I think that kind of gets to the point of the uniformity of your policies, in terms of, do you have in every business unit and every application, do you have it in every location, that kind of thing. So I think the key is to really define your layers for a particular purpose, maybe by application first, and then below that there might be, for some applications, there might be policies that apply, but for others there may not be. But you've defined that layer as that second tier. So what was your first layer again? I'm sorry. Voice over IP. So it was application. Yeah, okay. So basically you can allocate by application, and then it might be that you don't necessarily want to uniformly allocate to every sub-block of that application the same set of policies. So that's certainly a possibility. You don't have to allocate basically the full Monty, if you will, of addresses. I talked about the maximum, 16 for each nibble, 256 for 2 nibbles, etc. But that's really your upper bound. So you might have certain sub allocations below voice over IP, but if you have a different set of criteria, I would recommend creating that as a separate layer. So voice has a certain aspect. Maybe it's I don't know. Region or whatever. You need to make sure that your layers are defined homogeneously, but your implementation of the allocation of each layer may not be. If that helps. Does that make sense? Okay, great.
You touched on this kind of briefly toward the end. My question is, once you have an allocation plan defined all the way down to, let's say, the /64s that you want to use for your subnets in a data center, do you have some guidelines on when to use Slack and when to use statically configured servers where you map a existing v4 address to a v6 address?
In terms of, okay, so in
other words,
mapping.
Whether to use Slack or whether to go in and manually configure a v6 address.
Right. Yeah, so it's basically mapping the MAC address to the v6 address. Okay.
Or a v4, IPv4 address where you take the
map
to v4 and you put it in the last 4
yeah,
hextechs
okay,
of the v6.
Like a mapped address. Okay. Yeah, I think, a lot of the security people will tell you that's probably not a good idea to map the v4 address to, a v6 address. And the reason for that is that if I know what a given host is by its IPv4 address, and I can figure out that you've mapped the v4 address into the v6 address, I can, more easily determine that that's the server I want to get to. v4 is pretty well blocked off, but v6 maybe isn't as mature with respect to your security implementation, so I'm going to try to attack it that way. So that's generally not a recommended approach. But in terms of statically defining, certainly for devices that you don't want addresses to change really at all, like routers, maybe switches, other IP addressable infrastructure that you want to remain static, totally static, I would recommend addressing them as static. Now, other things like printers, maybe servers that you want to have be long length addresses, that you can influence through the address lifetime settings and allow them to use Slack if you desire, or using DHPv6 where you just set, certain, you can either set up like a reserved address or manual DHCP address to give a certain DUID, a given v6 address, pretty much infinitely. Or if you're using Slack, you can define the address lifetime that you want that address to exist and go from preferred to deprecated if you need to change it out. So I think the trade-off there becomes, if you are statically addressing, if you do have to do a renumbering for whatever reason, you've got all those devices need to be renumbered, in however way you configure that. Whereas if you're using either just a DHP pool or a manual DHP assignment, or using Slack, as long as you have reasonably lengthy but not infinite address lifetimes or release times, then you can more easily, make a change should you need to.
Thanks.
Sure.
Any other questions? Well, you answered them all. You guys all fall asleep after eating? Was the food good?
Maybe that's the problem.
How do we get the IPv6 deployment and management book that you are talking about?
Well, as I mentioned, we are having a book signing at booth number 1. So I invite you to stop by while supplies last. So we are, giving those away, a certain quantity that we have here. So, and then, we also have our IP address management tool, obviously on display as well. And if you don't like cutting and pasting or typing in v6 addresses, we have a solution that enables you to basically enter your RIR or ISP block, and then from there on, just using mouse clicks to allocate address space in a very straightforward, logical fashion. We'd be happy to demo that for you as well.
Any other questions? Otherwise, you guys are stuck with the ones I got that I wrote down. All right. So I was going to ask you about sparse allocation /48s. Is that your cutoff? Is that your determining factor? You're going to do sparse allocations at 48s, 32s, 36s. You're always going to count that way. But once you get below a 48 for a site allocation, your strategy, I assume, changes.
Yeah, I think so, because and I wouldn't really draw a hard line on a given number. It really depends on what your initial allocation is.
Mm-hmm.
If I'm given a 48, obviously that doesn't play. But it's really a relative, policy, I would say. So I would say at your top level, certainly it makes sense. If it makes sense for you, sparse makes, in general, is a good idea to, again, leave room for growth. But I would say it's not so much the CIDR length, it's more the layers down in your allocation. So if you have a 32 and you allocate, let's say, the first nibble and you're down to a 36, you could still do sparse below that. But if you keep doing it per nibble and you're down to the 4th layer and you're down to a /40, well, it may not make as much sense to do sparse at that time. So after 2 or 3 layers, it probably doesn't make sense to sparsely allocate. Again, depending on your growth projections, if you expect that particular function at that layer to grow, then maybe it does make sense. So, but generally, we've seen more at the top layer, sparse makes sense. As you move down, more of a monotonic or perhaps random allocation, just to kind of hide those allocations from a security perspective, might make sense as well.
So I'm wondering kind of which comes first. I mean, do you go out and get an address, allocation and then start planning it, or do you plan out something and then go try to get, what the size you planned?
Yeah, that's a good question. I think ideally, if you do some planning with a given block size, and really depending on how many layers you have and the size of each of those layers, that will help you define your optimal subnet, the middle bits there, the length that you desire to get from your ISP or RIR. So that's probably a good idea to do that exercise, to really use perhaps the reference block, and maybe use 32, maybe try it with a /40, et cetera. And then experiment with that in terms of its sub-layers. And if you end up, with getting a /56 and you want to allocate multiple, more than 4 layers, you're kind of out of luck there. So I think it is a good idea to exercise, a couple different alternatives, scenarios on your address plan, and then, see if you can request that size. Of course, you'll have to justify it if it's enormous. I don't think you'll get a /20, but, again, if you can justify that through your address plan, that might help. So, good question. Thank you. All good questions. Yes.
So you just used a magic word, which is justify, and in an IPv4 world, we kind of know what that means, but what the heck does that mean in an IPv6 world?
Yes, that's a good question. It really is going to depend on your RAR policies. I know Aaron's here. I don't know the exact current policy definition, but I think, in terms of V6, it's not certainly as stringent as V4 in terms of utilization. In fact, the measure of utilization changed from V4 to V6 as well. So it's using a different, log algorithm. So it's a little more forgiving, if you will, in terms of your utilization. So I don't know the policy offhand in terms of the proof of getting more address space, but certainly getting an initial allocation. Again, depending on how much you're asking for, depending on your organization size, various criteria in the application can influence that.
Yeah, my experience has been that you're not worried about addresses. You're worried about how many sites you want to run, how many subnets you want to operate. And that's the controlling factor versus in V4, we were always worried about how much address space are you actually using out of the addresses that we allocated to you.
Right.
And you got a /64 automatically with 18 million, bajillion addresses. You're not worried about how much you're using out of the /64. So you're really worried about how many networks you need to operate, right?
Yeah.
Is that a fair
Makes sense.
statement?
Makes sense.
And I wasn't here for the very beginning of your presentation, but how do we solve multiple ISPs when I thought the rule is only one ISP can route one prefix, so it's not like I can purchase two ISPs, for diversity and failover, and I have my block.
Right. Yeah, well, if you have provider independent space, that certainly makes it a lot easier, because now you can send that route. If you got a provider aggregate from that ISP, obviously they're only going to route their space that they gave to you, not perhaps another space from another ISP.
So is there independent where I can have two ISPs route my same space?
If it's provider independent, typically, as you said, typically an ISP. It depends on the ISP policies, and if they can be convinced to route another ISP's V4 space, but in general, they typically just want to route their own, because that kind of creates a hole in their routing table if they got to advertise different space outside of their realm.
Hi. What are your thoughts about the regionalization of address space? What are your thoughts about whether or not people are going to stick within the regions? So, for example, my U.S. or my North American space really staying in ARIN and actually pursuing space in APNIC or LATNIC or wherever. What are your thoughts about using, say, my ARIN space somewhere else, or how do you think that's going to end up playing out in the world?
Yeah, that's a good question. It's actually an active issue right now among the RIRs in terms of, allowing you to use space from ARINs, for example, and advertising that around the world. I don't think that there has been a consensus on a policy for that, for routing out of region block space. But I think the recommendation is to keep it within region. I don't know, Ed, if you had any more color on that, but that's basically the general guideline right now. If that changes, that could change in the future. But again, it just builds up the routing table, and at the core layer of the internet, they want to try to minimize impacts on that as much as possible.
Was there another question? Someone else?
I think there was one in the back there.
Was there another one? Oh.
Sorry. Hi, Aaron Hughes. In this case, Aaron Board. On this particular issue, first, the use of IP resources outside of the Aaron region. The only current issue is for getting subsequent allocations. You can use your IP space anywhere you want to. It's an IP address. I think the sense of the community so far, at least from what I'm hearing, is that you will be able to use your resources anywhere to justify subsequent allocations, and that looks to be moving along. So you're certainly right in the sense that it hasn't been clarified entirely, but there's a huge difference between planning as an enterprise and planning as a service provider, and certainly planning as a global enterprise. You're going to want to use your resources everywhere.
Yeah. Thank you.
And my humble opinion is go for the chaos monkey and someone else's problem. Right?
There you go.
A routing table problem, someone at 512, forget all that stuff. Right? We don't have to worry about that. I think we're at time, right? So thank
Okay.
you very much.
Thank you,
Appreciate
Ed.
it.
All right. Thank you.